The following is brought to you by Total Seal Piston Rings, the leader in ring seal technology. TotalSeal.com. Hidden Horsepower by Total Seal is back. Hello, everyone. I'm Joe Costello, and we have got another great show for you engine buffs out there. The people who want to know how and why engines make power. Hidden Horsepower by Total Seal gets the job done. And, of course, my co-host, he's the Director of Technical Sales at Total Seal, Mr. Keith Jones, is here. Keith, hello and welcome.
Well, hi, everybody. Thanks, Joe, for the introduction. Glad to be back. It's a beautiful sunny day here in Phoenix. Looks like we're going to hit 80 for the first time this year. Trying to get all you Midwesterners jealous. And my sincerest condolences to those in the Tennessee area that have gotten hit with the tornadoes. What a tragedy. Like I say, it's a blessing to live in a state where not much happens other than heat.
That is a fact, Keith. We have got a great opportunity this week. We have been running the All-Stars of Engine Building on Hidden Horsepower. We have got another one today. Jon Kaase Racing Engines. He's a 9-time engine master. Started out with Dyno Don Nicholson. So here we are, back to our drag racing roots.
Yeah, and here we are. We're with Jon Kaase. Those of you out there familiar with the name know him, the man, the beast, the legend, 9-time Engine Masters champion, king of the big Ford. I don't know what to say. As I was talking to Joe about interviewing Jon, I said he's the Grumpy Jenkins of today, and I mean that in the kindest, most complimentary way, because Jon's a thinker. He comes up with ideas. It's those ideas that you look at afterwards. You go, well, I get that. I could have done that, but it wasn't you that came up with it first. It was Jon that came up with it first. And again, anybody in this industry that doesn't know that name, you need to Google him and see the things that this man's done, because he's really done a lot and really pushed this industry forward. Some of the stuff he's done on Engine Masters, the Pontiac especially. I mean, some of the things Jon's done there just kind of blew my mind. It was in an awesome way.
Very excited to speak with him seconds away. We do want to encourage everybody listening to Hidden Horsepower to subscribe on Apple Podcasts or Spotify or SoundCloud, wherever you get your podcast. Write a review if you like it, and check back when new episodes drop. We're going to have more of the all-stars of engine building. So without further ado, let's bring him on the show from Jon Kaase Racing, a 9-time engine master, Mr. Jon Kaase. Jon, welcome to our show.
Hey, thanks. I'm glad to be here.
So all those things Keith said, do you agree with him?
Yeah, I was wondering who they were talking about there, but yeah, I guess most of that's true. It takes a while, but yep, that's me.
So Keith, where do we start with Jon in that his experience is so wide-ranging from early days of Pro Stock, but I have to say my personal experience has been with his mountain motor engines. Like, I see them everywhere, and I am, widely impressed and, frankly, an innovator from the beginning.
Yeah, absolutely. I mean, go walk around we'll say the Pro Mod pits, and my first time many years ago, experiencing Jon stuff was with the IHRA Pro Stock stuff, and you could literally walk through the pits and do inventory. Kaase motor, Kaase motor, Kaase motor, Kaase motor. Another brand, a Kaase motor. Just they were everywhere. Not to say that he owned it, but pretty much, because they're everywhere. And Jon's just taken that knowledge and expanded it into everything. I mean, from like you and I, Jon and I were talking at the PRI show. He's working on Mercury Marine outdoor boat motors these days, trying to work on that. And I know he's done a ton of stuff with GTR Nissan engines for the guys. They're doing those flying mile runs and. It's pretty exciting. Jon's a real innovator, a real thinker. I've been privileged to sit on some of his AETC conferences that he's done. And, like I said, he comes up with some pretty neat ideas and some pretty crazy ways of proving those ideas. And I especially remember the one, Jon talking about drilling the hole in an intake manifold and sticking his finger in it while it's running so you could feel the pulsations through the intake tract. I mean, you go there and you go, well, that makes perfect sense. But, again, Jon's the one that did it.
Well, that deal was a little bit on the dangerous side, and you can find some videos on YouTube if you look hard. But mostly it was for AETC conference presentation that I did, and I wanted something good to show, and I always kind of wanted to do that and to see what those pulses felt like in there. So if anybody is trying to imagine what we did, we had put in a tunnel ram on an engine that was about a 900 horse engine. We put a little eyelet in the middle of the manifold, or one of the runners, and you could put your finger in it. It was like a little grommet, and it had a hole that was a little bigger than your finger, and when you put your finger in it, it closed the hole off, and you could feel the air and the pulses going up and down. And it wasn't anything like we thought it would be. It was completely different than what we were expecting. But before it was over, we had probably everybody in our shop did it at least once or twice and we made full bore dyno runs on the motor. And of course, we're worried about it blowing up, so we had a 1/4-inch steel plate all the way up from the floor to the manifold. So if it shot parts out, it wouldn't hurt us too bad, But it's completely different than what you might think. It's cold. The minute you go wide open with it, it drops about 30 degrees because of the refrigeration effect of the expanding gases and stuff. But the pulses was what really got to us. If you held your finger the wrong way, it would almost break your finger. And it wasn't going down. If you closed your eyes and tried to imagine, it was violent both directions, and it was more violent going back up the manifold than it was going down, that shock wave. And it's unexplainable, really. But if you held your finger sideways, I feel sure you would have dislocated a knuckle. But you couldn't hold your finger steady. It went up and down with the pulses, and it was wiggling around. It was something.
Allow me to jump in and say, the guests on the show are not telling you to do anything that you should not be doing, and always take safety and precaution. Thank you, Total Seal. Yeah. All right. Keith, a question for...
Big disclaimer across the bottom,
Exactly.
Yeah, you don't want to do that. We thought a little bit afterwards about, what happens when you break a valve off in a motor. Sometimes all that trash goes up the port, and it goes back in the manifold. So, I was really glad that we never... And I think we're probably done doing that. I don't think they expect to do that again. But, you might just lose a finger doing that if you're not careful. So... Not a good idea, but it was pretty enlightening. It sure wasn't anything like a flow bench.
I can imagine. Jon, let's start from the beginning, as we have with all of our guests on the show, in that you worked with Dyno Don, starting off in NHRA Pro Stock back in the day, factory hot rods, that kind of stuff. But where did your original passion for engines or racing, or what was first? Where did it start?
Well, I think I grew up in the right part of the country for that. I was in northern Ohio, and around there in Detroit. This was in I became driving age about 1968, and that was just the 2 or 3 golden years there for supercars coming out of the factory and stuff. So the timing was perfect, and I always liked mechanical things, and I hung out with guys that were all motorheads at car nuts and stuff, and we just started building our own hot rods, and by the time I was 16 or 17, we all had race cars. The good thing was, in those years, I worked at a lawnmower shop, and I could field a race car off of my lawnmower money, which today would be a little bit tough. We kind of progressed along and just kept building other cars and building motors for people, and didn't have quite enough equipment to really do things 100% right, but that's pretty much the way it started. And then when I got in with Dyno Don, I worked with him for several years, and then in 1980 started my own business back up, and so ever since I've been on my own since 1980.
The evolution of parts and pieces, piston rings in particular, something we talk about here on Hidden Horsepower. I think about what you had to use then as opposed to what you have to use now. Talk a little bit about that evolution.
Well, there's a couple things that have happened. And I don't think anybody has any better stuff really than Total Seal's rings and their knowledge that they help you with. But there's a couple different things that are really important, and the one of them is the piston, and the other is the honing, and then what you're using for rings. But it's back a long time ago when we were building engines, we certainly weren't too sharp on how to hone a block. Certainly we could make it look, and it might look exactly the same as it does today, but all the numbers weren't exactly right, and you would never probably do two that were the same. But but the big thing was the quality of the rings has come along so far, and at the same time though, the most huge thing is the piston companies are doing such a better job with ring grooves than they used to do. And there was a time, I guess it's been almost 20 years ago, but I went to Rear Morrison one Saturday. My son was playing travel hockey out there, and I went to visit them, and they were putting ring grooves in some pistons on their big lathe, and a guy was sitting there really delicately putting ring grooves in. And when I came home, I started thinking about it more and more, and I started checking stuff on some of the pistons we were using, and we bought a bunch of little pin gauges and stuff when we were putting them in the ring grooves. And you put a pin gauge in there that's the right size, and it'd get it into the middle of the groove halfway to the bottom, and all of a sudden it'd get tight, and if it was toward the outside, it would wiggle a little bit, and you put it all the way to the bottom, it wouldn't even go in. So, we almost had some pistons we didn't almost, we for sure had some pistons that had a groove that was almost like a miniature keystone groove. It was wider at the outside than it was on the inside, and really when you get down to it, to me that's the most important sealing area of the whole engine, more than the cylinder walls, more than anything else, is the bottom of the ring and the groove that it sits on. And in other words, the land between the top and the second ring, that surface there, and the surface of that ring is so hugely important that if it's off a little bit, it'll blow all the oil out of the pan. It'll blow it out of the valve covers, and so we learned about things like that. But what happened was, we went and bought a lathe, and we used to put our own ring grooves in. But probably about 15 years ago, it seems like all the piston companies really got good at doing grooves, and they just use really good equipment. I think some of them use CBD cutters or something, diamond cutters and stuff like that, and the surface is so good anymore, so it makes everybody look good. It makes the engine builder looks good. It makes Keith look good, because their rings really do good on those things. And then Total Seal does a good job of lapping the bottom of the rings and the diamond lap stuff and all that. So the piston companies came up to speed, then the ring companies came up to speed, and after all that, then people got a little bit better with figuring out cylinder wall finish and how important that was, and grooves and how deep the valleys are in the grooves and how much they hold oil and stuff. So all those three things in the last 10 or 15 years have really come together. And today, if you'd have to be pretty lame if you didn't get the cylinders to seal up good.
Well, I agree with John. I'm going to touch on a couple of things he said, and absolutely the truth. We keep kind of pushing each other. The ring grooves and the pistons started getting better, and that forced us to make better rings, and then we were making better rings, and they could make grooves, and that forced them to make their grooves better. And it's just this constant improvement, and it's not just pistons and rings; it's everything. You think of valve train technology from 20 years ago compared to today, and as John said, each time we made it better, you revealed the next shortcoming. And then we started looking at cylinder, finishes, and how can we improve that? Because the blow by is better, but it's not as good as it should be. And we start looking at the finishes, and then with the modern machines, bore geometry, how straight and round the bores are. I mean, all of those things. Every piece of this, like we've talked about before, it's links in the chain, and we have to elevate all of them together. Just making a better ring isn't going to solve the issue. Just making the groove better isn't solving the issue. They all have to work together, so we have to elevate all of them at the same time. And like John said, if we get we do such a good job with the ring, if the cylinder finish is right, it's pretty much instant seal. There isn't a lot of break-in time involved these days if everything is done correctly. But I also wanted to touch on the ring groove thing. Go ahead, John.
Oh, I was going to say, a lot of the blocks we use today are much better too. Years ago we were using iron blocks they got awful thin on us, and we weren't really good about knowing that something that was that thin was going to be flexing around, and that made things worse also.
Oh, absolutely. The blocks are so much better. But one of the things that you touched on, and there's the simple tool out there, the gauge pin. And it's something every engine builder, and I know Jon has them and beyond, but every engine builder should have. I mean, if you're buying pistons that, let's just say, have a 043.5 ring groove, which is a common top groove size today, you should have a 43.5 gauge pin. They're not expensive. You can buy them at a ton of different places. And where I run into this a lot is on rebuilds. I'll get a customer that rebuilds an engine, and it just doesn't come back to where it was before. The blow by is not as good, the power's not as good, it's just not as good. And more times than I can tell you, we spend time on the phone, we go over bores, finishes, how to hone it, what kind of braking oil did you use, yada yada yada. And when they finally get down to it, they check that ring groove. The piston might have. I can tell a quick story. Lance Line, Jason's brother, had an engine at 150 passes on a super comp motor. Simple rebuild, nothing special, won't come back. Blow-by's not as good, vacuum's not as good, nothing's as good as it was. We spent a lot of time on the phone talking about it, and finally I said, Lance, you need to gauge pin those grooves. I'm telling you, the groove is, as Jon said, it looks like a keystone. It's turned into a wedge. It's not flat on the bottom anymore. Sure enough, he got a gauge pin, checked it. He put it in, like Jon said, nice and tight in the bottom, but yet it's wiggling up and down at the front. He checks. He got about 1.5 thou of taper in the land and only 150 runs. He bought a new set of pistons. They were just a shelf piston, put it all back together, same rings, didn't change the rings, and bang, everything came right back in. So that's we'll say a word for everybody to be looking at. If you're going to reuse the pistons, you need to double check those grooves before you put it back in. Make sure it hasn't hammered the ring grooves out, because if you've got a little detonation in an engine, a little fuel wash, it can take the grooves out pretty quick, and you can't see it with the naked eye. You need to check them. That's just something to look at. And sorry for being so long-winded, but Jon touched on a subject I hadn't thought about, and I wanted to hit that.
It'll bend them. Yeah, it'll bend the ring groove down a little bit. Sometimes they rise up because they overheat up there, and you don't really know exactly which happened. But if it's bent down and angled down a little bit, you got big trouble. And it's odd because you could take and break a valve off in an engine and have all kinds of pecker marks everywhere on the cylinder walls, and you could hone it back, and it looks like somebody blasted it with a shotgun, and it'll still make pretty good power. It won't be as near as bad as you think. But if that land isn't right, like I said, the most important area in the whole motor, I think, but if that land isn't right underneath that top ring, it's not going to make any power. It just won't. It just blows all the fire right by it. The rings don't push out, or nothing works right. And so it's huge. It's huge.
Jon, let's start talking about one of the things that I think you are perhaps most known for. I definitely want to spend a little time in the marine market side of things, in that it's got to be very difficult to make an engine live out there on the water. But I want to talk mountain motors, giant cubic inches, and the early days of them, because you were in many ways a pioneer. There were a couple. And the Boss 9, well-known out there, the valve covers, of course. But just take me to those early days of accomplishing that. That had to be very, you had to be creative, I'm sure.
Well, everybody, started with cast iron blocks. And at one time, about 500 inches was really big. And when I worked for Dyno Don, we built a 5/16-inch aluminum engine that was based out of a Ford 429, 460 style, with aluminum super cobra jet heads that somebody found around at Hallman Moody or something like that. And we raced against Jenkins, and Jenkins had a 494 big-inch Chevy, and that was about 78 or so, and it kind of just kept getting a little bit bigger and a little bit bigger from there. But we raced several years with 588-inch cast iron engines, and I think some of those had 5-inch strokes in them, which was huge at the time. That was in the early 80s. And then, we got up to about 650s or so. And then it seems to me like we went right about from, high 600s and all the way to 800 inches all at once, So there weren't too many 700-inch motors. We went all the way to 800, like within a couple of years' time. But, you're just building taller deck blocks and bigger bores. At one point, we made the bore center a little bit bigger, so we could have bigger bores in them, but basically the motor wasn't much different as far as, it wasn't much longer or anything. It was just the cylinders were moved a bit, but they just, everything progressed along. They just kept getting bigger, and then along with that, we had to use different parts, different camshafts and different amounts of compression, bigger valves. Everything just kept getting bigger and bigger for a while. And then it pretty much leveled out about 15 years ago, where Right now we're almost like the 500-inch stuff where you're really struggling to make them any better. We can make little tiny gains, but we've pretty much got all the low-hanging fruit. That's way behind us. Everything now is a struggle to make power, to make it better.
And on that note, early on we were having a conversation about secrets in the business, things that are proprietary that you want to keep secret that you may or may not want to put out there on this podcast. And you were very open about it. You said flat out that you're pretty much, I won't go so far as to say an open book, but you're beyond that.
Well, there's not enough people coming into the business of building these big engines. But the thing is, it's kind of funny. You see people hiding stuff when they're building engines and all. And most of the time, they're hiding it from guys that already know anyway. It's like there's only 2 or 3 guys you wouldn't want to be looking at your stuff, and they've already looked at it one way or another. So, it's you just have to hope you keep finding new stuff, and there's no real big secrets in a lot of these engines anymore. There's been too many people worked on them, and one of your customers will think maybe that somebody else could do better, and they send it down to somebody else, and it all gets mixed around, and pretty soon everybody knows that what everybody's got anyway. But there's really not enough new people working on these. That's not a real big secret type of deal anymore.
Keith, thoughts on the mountain motor stuff?
Love them. That's the best place for me to start. Love them. It's just sheer massiveness. I guess is the way to say it. It's just sheer torque. It's just sheer power. How these things get down the racetrack. I'll kind of reference back to Matt Hartford, our CEO, because Matt ran the 80 RL series, and he had a big inch motor and pro stock, and he said, hey, it's the difference between a 4-stroke dirt bike and a 2-stroke dirt bike. That 500-incher, you just got to keep it right here. That mountain motor, he goes, I can screw up all day long, and it's just got all the steam in the world to make me look good. And won a championship doing it. It's just, I love watching them. It's just sheer grunts excitement.
Well, they turn a lot of RPM anymore as far as a big engine goes. They'll maybe go 8,600 or so, and that's a pretty good load on all your parts in there. On a supercharged engine, there's a little bit of cushion of air above the piston, helping it slow down just a bit. And on a big inch motor, on overlap that's naturally aspirated, when the piston's changing direction, on overlap there's nothing to stop it other than the rod and the rod cap, and so it puts a huge stress on the lower end of the motor trying to change direction all the time. I think that the number is maybe 24,000 pounds of load on the rod bolts. When it's at top dead center, it's trying to stop it and change it, go back to the bottom. So there's a huge amount of force there. Well, it's like a wrist pin lock. The little tiny lock weighs 30 pounds when it's changing direction. That's how much inertia it has, and if the wrist pin locks aren't strong enough, they'll bounce up out of the groove. Things like that.
Wow.
Things that you don't think about. I don't know how much a ring is going to weigh more than that. So think about that once.
I'll just touch base. What John just said is absolutely true. I have a customer of mine that did a 4900 bore motor as far as bore size, and tried to turn the thing up really hard, as John just indicated, over 8,000 RPM. And I actually have it here. I wish everybody could see it, but they didn't do the math calculations like John just talked about and look at piston speed. And third hit on the dyno, it split the pistons in half inside the oil ring groove. So if you can imagine, a top half and a bottom half, kind of like a 2-piece diesel piston, didn't really hurt the engine, but it was simply the forces that it was dealing with trying to turn that kind of RPM, moving that much weight, and it literally split all the pistons in half.
The inertia is tremendous. I mean, there's about 80,000 piston to head clearance total. In other words, if it was a flat top, it'd have 40,000 stack and a 40,000 gasket, and they'll hit. I mean, it's certain they'll hit at 80, and it's a little bit of it's the aluminum rod getting warmer, but that's only about 10,000ths of it. The rest of it is all that inertia trying to change directions. It's pulling on the crankshaft. it pulls on the crank so hard that it actually shortens the crank up. There's all kinds of things that happen that you never would guess. It's just unreal.
It is amazing, and I am happy that I am doing this because I speak well, but there are times like this where, man, I wish I was better at math, because being able to do some of those calculations, right, like thinking about times the force of gravity and the weight of something that's light increasing exponentially because of the forces it's under, like I just did at 8,600 RPMs, that thing is spinning 143 times a second. Like, that doesn't make sense to the normal person.
No, it's hard on those parts, and it's funny because a turbocharged engine, well, they wouldn't be as big, but a turbocharged engine or something like that has boost, and it's actually got a little cushion in there helping the piston slow down when it's changing directions. But with a big NA motor like that, naturally aspirated, it's got nothing to stop it other than the connecting rod, and it's trying all it can do to rip the cap off the connecting rod when it's changed direction. It's unbelievable. Good thing we have good parts today in connecting rods and wrist pins and pistons and stuff. Those companies have really done their homework and made some mighty fine parts.
Now let's talk diversity. Another area that you are involved in is offshore and marine water-based horsepower. And that's an area that we have yet to get to, Keith, here on Hidden Horsepower, but we've both been very excited about it because of the undulation of the water, the torture chamber that is the marine industry. I know that they really go over and above to deal with just a million different elements that we don't have on asphalt or pavement racing, as we would say, drag racing or otherwise. How is it different building an engine for a marine environment? I knew you do some stuff for offshore power boats. You do some outboard engines. Those are different in and of themselves. But in terms of what we're talking about here, piston rings and seal, it's got to be very challenging.
Well, I don't really know that there's a lot of the parts were done totally different just because it's going in the water. A lot of the accessories have to be different because if they're salt water, everything has to be stainless, and you're gonna have trouble with all the bolt-on stuff. But some of the engines that we work on are twin turbocharged Mercury Marine engines they call them a QC4. It's a 560-inch, all water cooled, completely unique engine that Mercury built. It's a real masterpiece of a motor. It's like a huge Coyote Ford. It's twin overhead cam, 4 valves per cylinder, 2 water-cooled turbochargers on it. They've got all the coolers on the motor, cooler oil or water to oil, water intercooler, stuff like that. Then water to water, so it doesn't use ocean water in the engine. And there's hoses and clamps, and oh my God! And all that stuff's beating around. We had some videos in the engine bay of these boats. And the one that we really started on was this one that's called Miss Geico. It's a big yellowish 50-foot catamaran that runs about as fast as 180 out in the ocean where they race them. And what you see on those videos is all the tanks and the lines and stuff are flying around, and then those boats come out of the water. Sometimes they come out of the water 10 feet, and so you got your throttle guy, and they're trying to anticipate when it's going to come out of the water, and then they pull the throttle back. But they're turbocharged motors, and those things don't slow down that fast. They just keep going. So the constant in and out of the water is terrible on the engine. It's really hard on the crankshafts and the drives and stuff. So it's just like it's a war of attrition. If you can just finish, you're doing good. They might be 80-mile races sometimes, and it's like an oval. It's like a big Daytona on the water that's 4-mile oval, and they just get beat to death. And if it's a smooth day, then it's going to run faster, but it's also going to have a lot more RPM, and that's rough on it. And then if it's a rough day, it'll run slow, but it's beating it up and down coming out of the water and crashing down. And there's other things going on, like the oil and they're dry sumps, but the oil in the oil pan isn't necessarily going to the pickups if the thing's got negative G's and stuff and it's up in the air. And there's all kinds of things that happen that you just don't think about in a drag car. You don't always have G-force holding the oil in the right place in the oil pan, and so the pickups get it. And there's just I'm not going to say it's awful because we enjoy it, but it's tougher than you would think.
Well, what John just said, it's again, I'm still kind of bathing in what he just said, because those are things, me being we'll say, not to say I'm locked into one thing, because I love just about every form of motorsports. Just saw a thing the other day on cross kart racing, which looked wildly exciting. But like John just said, the negative G's, and that's one of those things that just, light bulb went off in my head. That boat, as it's coming back down, just like, going up in an airplane and dropping back down, that oil's now, it's weightless, so it's coming up away from the suction lines, trying to wrap itself around the crankshaft. So, like I say, I'm just kind of bathing in the thoughts that he just put across. But in the marine world, John, obviously working with all the Mercury stuff, and I am familiar with that engine, and it is a masterpiece. But do you do much as far as, conventional or traditional, V8, whether it be Chevy or Ford? Not sure if you do much of that with those.
No, we do. We've got 3 or 4 of these things. I call them super cats. It's actually it's like pro stock of the boats. They're kind of a spec engine. It's about a 45-foot catamaran boat. That it's a big Chevy. They're 5, and they have a bunch of rules on them. They're unported heads, but they have dominators on them, and they have a lift rule and an RPM rule. It's like 7,000 RPM, and they make about 750 horse. And no matter who builds them, they're all pretty close to the same. But whoever drives and rigs the boat up and stuff usually ends up being the best guy. But they're really a cool deal. There's 2 of them in each boat, and they weigh about 10,000 pounds, and they run about 140 or 50. Now, I'm going to say 140, but they're out of they get up out of the water with that big tunnel down the middle, and the air holds them out of the water, and there's usually 6 or 8 of them at a race, and the first couple of laps they're really close. It looks like front row at Daytona. It's awesome, fun to watch, and they're neat to work on. It's a really cool deal. We go to some of those races, and one of my guys here drove one of them because they didn't have a driver the one day when they were doing some testing. So it's a cool deal, and we really enjoy it.
Well, I was just curious, John. Do you have to, building that, that 500-inch piece? Do you find any specific challenges, to that marine environment versus, say, the drag racing? Better, different rods, pistons, I assume, different clearances. I'm sure it has some fairly unique challenges.
Really, the challenge is just making sure it stays together, and you have to be careful with your valve train and all. You have to kind of curb yourself from if you try and run the harshest stuff you could possibly run, so it makes 2 more foot-pounds of torque, you probably won't finish a race, But everything has to be really good parts. I mean, the best cranks and rods and pistons and stuff like that you can buy. They're all heavy duty, and they'll go 7,000 all day long. They'll run 5 or 6 races on a motor before we see it again. But it's just like a little miniature pro stock deal. It just doesn't run quite the RPM. It's cool.
Outstanding.
Amazing. Now, what would you say, John, is the most unique engines that you have been working on? I noticed that the GTR stuff is going on. That's automotive, though. We talk boats, we talk automotive. But are there any projects that have come across or through your shop over the past year, 2 years, 5 years, et cetera, that was pure interest on your part because it was something that was unique?
Well, in the last year or so, we've actually been working on some outboards it's kind of they aren't actually racing these things in a class. They're more racing their buddies. They're kind of match race each other and stuff down the Florida area. And they're it's an inline 6 that's a Mercury Marine. I think they call it Verada. It's a 400 horse motor. But when you get down to it, and you just what they call the power head, which is the business part of that thing, when you take it off the outboard, it's an inline 6. It's got a screw blower on it. It's dual overhead cam, 4 valve per cylinder, intercooled, fuel injected. I mean, they're really something, and they're not huge. They're 158 inches or so. So they're already making 400. So to step it up another 100 horse or so it's really no easy task because it's already starting out really good power per inch, and so we've been working on a program for those, and those are one of the things that you take home with you as far as in your mind. You wake up at 3 a.m. and you're thinking, well, if I could do this, maybe it would be a little bit better. But we're still a little bit. We're not 100% sure of a few things. So we worked on four or five of them. We've been doing a lot of dynoing on them here at the shop, but we still have to find out a few more things about how they act in the boat before we're full bore on doing them for people. We're not 100% sure about the exhaust, where it comes out, and if it's got back pressure and things like that, because we don't have a boat here to put it in, and the exhaust comes out the middle of the propeller, and there's a bunch of unknowns we're still working on, but that's a cool project. And that's another masterpiece of an engine. I mean, it's really nicely built, and those guys have to build those things and give them to people and give warranties on them and stuff, and they're out there racing around in them, so they do pretty good at staying together, and they probably make 3 horsepower per inch or something the way they come.
Can we put one of those in a competition eliminator dragster?
Yeah, I would guess you could. You might have to redo the oil pan a little bit because they're used to standing on end, But they're actually, if you look at some other racy stuff like some of the Nissans and Toyotas and that are inline sixes, they're very similar. Very similar stuff. It's pretty cool. The only thing is, it's got water cooling everywhere, and the way the water works. But it took us a little while to get up to speed on running them because we had to kind of build a dyno for it. But they're coming along. It's something that's different and it's fun to work on.
Keith, any final thoughts on that before we move on with John?
No, I agree with what John says. You look at the modern engines that are out there today, and these are really, I'll call it slightly detuned race engines. You're dealing with a lot of very high-end companies that are designing these, and if we're looking at X amount of power out of X amount of cubic inches with a given fuel, as John said, you're going to kind of end up with similar designs, combustion chambers, ports, port locations. We're using the same kind of programs to design stuff. I look at the 3 different, major brands of NASCAR engines, and though they're all different, they're still very similar. It's interesting how they're kind of all evolving to, again, there's differences, but the basic designs are very, very similar. And, the horsepower per cubic inch output out of this modern stuff just like I say, it blows my mind. John was talking about the V8 version in the motor, and I looked at one of those and got to see a cutaway version. It reminded me, back into the early 2000s of the Ilmor designed, Chevrolet IRL engine. I'm looking at a lot of things, and it's like very, very similar. And that was an 11,000 RPM IndyCar engine. Here it is now; it's a boat motor. And not taking anything away from it being a boat.
I think some of the that QC4, that big one that we work on, some of that stuff was done in England, I believe. They had some help from Lotus, maybe, or some of that. But still, it's just a big version of a big Ford Coyote in a way. It's huge.
Yeah. Like I said, I saw one at the Barrett-Jackson auction a couple of years ago, and kind of when that was, I don't know if it was first coming up. They had it on display, and it was a big cutaway. It was the first time I'd seen it. And it was very, very cool piece.
Yeah, but at the same time, the boats weigh 14,000 pounds when they're full of fuel. This is a race boat, so that's a lot of weight to get going.
Absolutely,
you need every bit of it to get it to go 180 with that thing. It's got to have pretty good juice.
Pure insanity. John, at the conclusion of all of our interviews here on Hidden Horsepower, we got a loaded archive of engine masters such as yourself. I don't know if anyone has won 9 times, though. We ask for a nugget of advice for the up-and-coming engine builder, the guy who is interested, who's hardworking, maybe a bit of wisdom that you have learned over the years that you can impart to that person as they begin their journey and start, working on these engines, maybe open a shop, maybe follow your footsteps in some way, shape, or form. Is there anything that you can share that you've learned over the years?
Wow, that could take a while. If you're getting into this business, the best thing is really find a place to work and learn it that way. Now I've got 3 guys here that work for me that went to the School of Automotive Machinists in Houston, and that place is awesome. I love those guys that work here, and the school is really good. So, I would say that we would hire more guys out of that school too. So if a guy's really interested, that's a pretty big commitment to go there. But I don't know if there's any place better, and they sure learn a lot. But if not that, you need to work at a place that has some good quality people that run it, and you need to be able to do as much as you can on your own. In other words, and that's the way I kind of always went around it. It was I couldn't wait on somebody else. I had to do it myself, and if I couldn't do it myself, then I had to learn how, and I had to figure out what equipment it took. But you just have to be careful not to run yourself out of money, and we still do that every day. We make sure we don't run out of money and buy too much stuff that you can't pay for. So there's a whole lot of things like that are sort of intertwined. You have to keep learning every day. Don't run out of money again, and that means like huge payments and stuff will sink you pretty quick. And if you can get in with a good group of people and learn from them, it's invaluable. It's like the guys that come here. If they didn't go to a school, and even if they did go to the school, there's a few people here that have been doing this for 50 years, myself included. We've got some older people here too, and all of a sudden you're getting 50 years worth of knowledge from somebody for nothing, and it's something that's hard to learn on your own. This whole business is you have to be like a sponge and absorb everything. And even here, the big thing too is we learn something new every day, and don't ever think you know all there is to know, because for sure you don't. No matter what, there's somebody better somewhere. So you just have to kind of keep humble and just keep working hard, and you'll get there.
He is a 9-time engine master, and amazing interview. Jon, thank you so much. We appreciate you for coming on Hidden Horsepower, and thank you for sharing so much information about your coming up right through to today. We really appreciate it. Thank you.
No problem. Enjoyed it, guys.
You bet. Thanks, John. Again, I really appreciate it. We'll talk soon. And again, I can't tell you how much I very much appreciate you taking the time to do this. I know how busy a guy you are, and it's hard to carve out that extra time every day. And again, thank you so very much, and thanks for being a great customer of ours.
Oh, no problem, man. I'm going to sign out.
There he goes, Jon Kaase. Wow, Keith, that is exactly why we do this show.
Yeah, exactly. He's like I said, anybody out there that doesn't know who he is, like I said in the beginning, Google him. Look at some of the things he's done. Look at some of the incredibly crazy things he's come up with his engine masters, winning engines. It's like I say, to me, it's mind-boggling, some of the things that he's done. And once you, like I said earlier, once you see it and you visualize it, you go, it makes perfect sense. But never would I've had that original thought. That's what makes Jon one of those special guys. Amazing stuff. Be sure to click subscribe, Apple Podcasts, Spotify. If you like what you're hearing, we've got more to come. And Keith, the thing that he mentioned about the rings, about the pistons, about the parts, about the pieces, it is all so true for the engine builder out there, whether they got an LS or a Coyote or something that they're working on that may be as exotic or not, and they can all give you a call to get started off with direction for their piston rings. Absolutely, they can. As I've said in the past, make us your first call, not your last. You're diving into this project, give us a call. That's what we're here for, whether it's myself or any of the other guys. We want to know what you're working on and help guide you down that path before you get down the path standing there going, wow, there's no rings, or I can't find what I want. That simple phone call or that email, you can contact me, Keith J. at TotalSeal.com, or any of the other guys here, and we can help guide you down that path to make sure that you have the most successful build and get the right parts that are right for what you're doing. And that's great. And on a future episode, Keith, we got to tell everybody about the big tour of the Total Seal factory that you gave me a couple of weeks back. I'm very eager to talk about that on a future episode. We got a lot of stuff coming up on Hidden Horsepower. I am looking forward to it. I did want to say thank you on the air for that. It was an eye-opening experience, and now I genuinely know what's going on behind the scenes and where you are when you're doing these podcasts. Yes, you sure do. It is an amazing thing. People, I've never had anybody come in here that I haven't shown the place to, and what we do that hasn't walked away going, wow, I didn't realize it was that complicated. Didn't realize there was that many steps to the processes, and there are. And most manufacturing is pretty involved, and a lot of people just don't realize what it takes to get it from that raw piece of metal to a finished part and in your hand. It's pretty involved, and I'm very, very glad to be able to give Joe that tour and show him a little bit about what we do.
Exactly. We'll talk a little bit more about it on a future episode of Hidden Horsepower. Keith Jones, thank you so much. A great job once again.
Appreciate it. Thanks for having me.
He's Keith Jones, the Director of Technical Sales for Total Seal. I'm Joe Costello. You can get me on Twitter at WFOJoe. More episodes of Hidden Horsepower presented by Total Seal to come. We'll see you next time.